All right, listen up, you clueless bunch. Today we're diving into the thrilling world of variables and arithmetic expressions in C. Yeah, I'm talking about the language that separates the pros from the wannabes. Now pay attention because I won't repeat myself. We're starting off with a program that converts Fahrenheit to Celsius. Yeah, I know, basic stuff. But hey, even dummies need to start somewhere. Take a look at this mess. We're using the formula C equals 5 divided by 9, multiplied by F minus 32 to print out some Fahrenheit temperatures and their Celsius equivalents. See these comments? Yeah, they're like your cheat sheet, explaining what the heck this code is supposed to do. Don't get too excited. The compiler couldn't care less about them. Now, let's talk about declarations. In C, you gotta declare your variables before anything else. There are the storage of your data. And don't even get me started on data types. We've got ints, floats, chars. It's like a freaking circus. But hey, that's what makes C so special, right? The type int means that the variables listed are integers, by contrast with float, which means floating point, meaning numbers that may have a fractional part. Integers and floats have limited size. It's like 32 thousands and negatives and positives on a 32-bit machine. So if you need larger numbers, use long and double instead. All right, brace yourselves for some action because here comes the loop. While far is less than or equal to upper, we're gonna keep crunching those numbers like there's no tomorrow. The while loop operates as follows. The condition in parentheses is tested. If it is true, the body of the loop is executed. Then the condition is retested, and if true, the body is executed again. When the test becomes false, the loop ends, and execution continues at the statement that follows the loop. The important part of the code is this line in the body of the loop, Celsius equals 5, multiplied by far minus 32, divided by 9. This arithmetic applies to every line of our array. In this example, it's not a real array, but just a number that we increment by 20 at each step. But hey, it gets the job done, so don't worry about it. It's simpler, all right? You know how to create an array in C, maybe? No? Then shut up. By the way, the equal sign here signifies an assignment. It means that we're assigning the result on the right side of the equal sign to the variable on the left. When we want to write an equality test, we'll use a double equal to signify equality, and not assignment. The reason for multiplying by 5 and dividing by 9 instead of just using 5/9 is that in C, as in many other languages, integer division truncates, meaning that any fractional part is discarded. Since 5 and 9 are integers, 5/9 would be truncated to 0, resulting in all the Celsius temperatures being reported as 0, which is cold. Now, onto the printf line. You'll notice we've used %d twice because we have two variables to print. %d is used for integers. The first integer after the comma will take the place of the first %d, and so on. So, of course, you need to include as many variables as there are % statements in your string. Otherwise, your computer will think you can't even count and will stop cooperating with you. Now let's make our print result nicer because right now it's shit. Let's say we want the number to be right justified. That's easy to fix. If we augment each % in the statement with a width, the numbers printed will be right justified in their fields. This way, it will print the first number of each line in a field 3 digits wide and the second in a field 6 digits wide, like this. A more serious problem is that because we have used integer arithmetic, the Celsius temperatures are not very accurate. For instance, 0 degrees Fahrenheit is actually about minus 17.8 degrees Celsius, not minus 17. To get more accurate answers, we should use floating point arithmetic instead of integer. This requires some changes in the program. Here is the second version. All right, listen up. It's basically the same as before, but now we're using floats for far and Celsius, and the conversion formula is written in a more normal way. In the old version, we couldn't use 5 divided by 9 because it would just round down to 0. But now by adding those decimal points like 5.0 divided by 9.0, it's all good because it's floating point math. And if you mix integers and floats in an operation, the integers get upgraded to floats automatically. So, when we say far minus 32, that 32 gets promoted to a float. And hey, using those decimal points for floating point numbers just makes it crystal clear for us humans. The print conversion specification, %3.0f, says that a floating point number, here far, is to be printed at least 3 characters wide, with no decimal point and no fraction digits. %6.1f describes another number, Celsius, that is to be printed at least 6 characters wide with 1 digit after the decimal point. The output looks like this.